Hello and welcome to another Tycho video. Today I am going to be demonstrating how to generate measurements of objects that have nonlinear motion. In other words, these are objects that do not follow a simple straight line path. So in this example, I have images that have been provided to me of object 2025 FA22. As you can see, there are 84 images here, and they span a total time of 2.1 hours. So with that, I'm going to proceed to load these images into the image viewer. So I go to Action, View Images. They've already been plate solved and aligned, so we do not have to worry about going through that entire process for this example. So as you can see, this is what the images look like. If I scroll through the data set here, you can see the moving object. So it is right here. So what we want to do is first validate that indeed it does have a slightly non-linear motion. So if I double click on the first image of the object and right click and choose Create Marker 1, I am defining the first position of the object, and then I can go to the last image in the data set, and once again double click to center it and right click and choose Create Marker 2. So I have now defined what would be the straight line motion if this object does in fact have that type of motion. But as you can see here, if I scroll through the images, the object does in fact deviate slightly from what would be a simple straight line path. So in this example, I'm going to demonstrate how to work with such a motion, such an object having this kind of motion. So to do that, one way is to attach Ephemeris of the object to the data set. So I can go back to the image manager, choose Ephemeris attach from JPL Horizons, specify the designation of the object, and then choose attach to dataset. So it is going to compute where the object is predicted to be located on each of these images. So as you can see, these columns have now been populated. And just to demonstrate this further, if I click on an image, you can see that the object is automatically centered in the crosshairs. Now, I know I've shown this before in a previous video, but I wanted just to demonstrate the concept of creating measurements of this object as well. So pretty straightforward. If I wanted to, I could create an observation right here of just a single image. But if I wanted to create stacked or observations from stacked images, I can also do that. So for example, I could choose selection, the first third images, and as you can see, this would be a stack from the first third images in the data set, and I could proceed to create an observation from that. Now you'll want to double check the options you have configured here. So it is currently creating a median stack. If I wanted an average stack, I could do that as well. So that's what that would look like. And you also want to make sure that it is on tracked motion. Now another way is if I wanted to choose an arbitrary set of images. So if I did not want to have just the first, second, or third set of images, I could choose a custom selection. So I could choose images 25 through 30, and then right click and choose Create Stack Ephemeris, and it will use the currently selected set of images. So that's what that looks like here. So as an example, let's go ahead and create a stack of images here, the first 30 images. So I double click and create observation, and then we'll do images 31 to 48 and create that observation, and then finally one more set of images 49 to 84. So I create the third and last observation here. So here we have 3 observations, and I go ahead and specify the designation here. And what we can do is now validate the accuracy of these measurements. So I can right click and choose view with published observations. And as you can see, it has downloaded all of the existing astrometry of this object, and it has also appended these most recent measurements here. So I can choose compute orbit, and we give it a moment here to do the calculation. So in just a moment we will see what the residuals of the measurements are. So these are dated September 30. So if I scroll down to that point in time, we see these three measurements. So R87 is the observatory code. So as you can see, these are the measurements that we just took. So these are very good residuals, so 0.02, 0.07. So these are all under 0.1 arc seconds in residual. So very good quality measurements that we just now generated of this object. And as you can see, it is in agreement with the surrounding measurements as well. So with that in mind, this hopefully gives some idea of how to work with these types of objects. Now, one question might be, what would happen if JPL Horizons did not have that object in their database? Well, you could still do it if you had astrometry. You could attach it from Find Orb. So Find Orb can create an orbit and generate ephemeris accordingly. So as you can see here, we've generated a computed orbit here using Find Orb, and I could choose ephemeris attached to dataset. So this could be some random object, maybe a newly discovered object that is not in the JPL Horizons database, and we could compute its orbit and attach it to the dataset as one example. In a subsequent video, I will also show how to do this same kind of measurement on artificial satellites that, again, maybe you generate measurements of those and you want to do photometry work, you want to construct a light curve, and so those are also objects that tend to deviate, or very often, more than not, they do not have a simple straight line motion. So that's it for this video. Thank you for watching, and see you next time.